Hey, Math Mom here, and today we're going to talk about factors. We're going to look at three parts of factors. We're going to look at what a factor is, we're going to talk about prime factorization, and then we're going to find greatest common factors. So let's start with factors. Factors are all of the numbers that divide evenly into a number. Factors are all the numbers that divide evenly into a number. So if we have the number 10, if we list its factors, we would say 1 times 10 is 10. So therefore 1 and 10 would be considered factors of the number 10. We could also note that 2 times 5 is 10. So 2 and 5 are also factors of the number 10. So if we list our factors for the number 10, it would be 1, 2, 5, and 10. Let's look at the number 24. If we are to list all of the factors of 24, what would we get? Well, 1 times 24 is 24, so we know 1 and 24 are going to be factors. 2 times 12 gives us 24, so 2 and 12 are going to be factors. 3 times 8 is 24 because 24 divided by 3 equals 8. So 3 and 8 are factors of 24. 24 divided by 4 is 6. So 4 and 6 are going to be factors of 24. So if you list your factors of 24, it's 1, 2, 3, 4, 6, 8, 12, and 24. Let's talk about the number 31. What if we were going to list the factors of the number 31? Well, all we come up with are 1 and 31. So 1 and 31 are the only factors of the number 31. That's because 31 is considered a prime number. If the only factors for the number are 1 and itself, then the number is called a prime number. A prime number only has two factors, 1 and the number, so like 31. Other examples of prime numbers are 5, 7, 11, 23, and I bet you can come up with even more. A prime number is only divisible by itself and 1. So let's get back to listing factors. If we were to list the factors of the number 27, you try it first. If you want to, pause the video and list the factors of 27. If you listed 1, 3, 9, and 27, you're correct. Those are all of the numbers that can multiply to give you 27. 1 times 27 is 27, and 3 times 9 is 27. So those are the factors of the number 27. You try 18. Pause the video if you want to try to write the factors on your own. If you wrote 1, 2, 3, 6, 9, and 18, you're correct. You've listed all of the factors of the number 18. So let's review our two types of numbers again. A composite number has more than two factors, such as the number 18. We listed all of them. A prime number, such as the number 31 or 11, only has two factors, 1 and the number itself. Now, why do we need to know what prime numbers are? Because now we're going to talk about prime factorization. So our focus is going to be on prime numbers as we write the factors of another number. So prime factorization means what are all of the prime numbers that multiply together to create a number. So we're looking for only prime numbers, and how many of those prime numbers, or what numbers are they that are going to multiply together to create a number. So if we look at the number 18, we are going to find what two numbers multiply together to give us the number 18. 2 times 9 gives us 18. So 2 and 9 are factors of 18. 2 times 9 equals 18. So we're going to circle the number 2 because 2 is a prime number. And so then we're going to go over to the number 9. Is 9 prime? It is not, because more than just 1 times 9 gives you 9. So then we're going to factor down a little bit lower, and we're going to say what two numbers multiply together to give us 9. That's 3 times 3. So we're going to circle 3 and 3 because they are both prime numbers. So if we are going to list the prime factorization of 18, it's going to be 2 times 3 times 3. Now there's another way to write the prime factorization of 18, and that's using exponents, which is that small 2 on the bottom line. So the other way to write the prime factorization of 18 is 2 times 3 to the second power. That means how many 3's are there? There's 2 of them, so it's to the second power. So that's how we would write the prime factorization of the number 18. Now I want to look at how there's 2 different ways for the number 18. Some numbers have multiple different ways to get to the same answer. So for the number 18, if you didn't do 2 times 9, you could have written 3 times 6 because 3 times 6 also gives you 18. Then we would have circled 3 because 3 is prime. Then when you look at the number 6, it's not prime. So what 2 numbers multiply together to give you 6? 2 times 3. So now we have all of our prime factors that multiply together to give you 18. And again, I wrote it the same because we always write prime factorization in numerical order. So starting with the smallest number, going to the largest number. But just because your way looks different than my way doesn't mean it's wrong as long as we have the same answer. So now you try, or let's look at the number 54. We know that 6 times 9 gives us 54. So let's write that down as our first part of our factor tree to find the prime factorization. Now 6 is not prime. So what 2 numbers multiply together to give us 6? 2 and 3. So we're going to circle 2 and 3 because they are prime. Then we're going to move over to the number 9. What 2 numbers multiply together to give us 9? 3 and 3. So now we're going to have all of our prime factors listed out. But when we write them in order from smallest to largest. So the prime factorization of 54 is 2 times 3 times 3 times 3. Now how many 3's is that? 3 of them. That's right. So 2 times 3 to the third power is another way to write the prime factorization of 54. I want you to try the number 30. Pause the video now if you want to be able to work it out on your own. If you wrote the prime factorization as 2 times 3 times 5, you're correct. There's 2 ways to get here because you could have done 3 times 10, or you could have started with 2 times 15. I did 3 times 10, so mine may look a little different than yours. But if you got for your answer 2 times 3 times 5, then you also did it correctly. Great job. We're going to move from prime factorization to finding the greatest common factor. So the greatest common factor is the largest number that 2 numbers have in common, 2 or more numbers. So we are looking for the greatest factor that 2 numbers share. We could also ask ourselves, what's the largest number that both of these numbers can be divided by? So let's look at an example. The numbers 18 and 27. If we are to list the factors of each of these numbers, I've listed them below. We did them earlier in the video, but we have 1, 2, 3, 6, 9, and 18 as the factors of 18. Now remember, we're not writing the prime factors. we're writing just the factors. What are all of the combinations of numbers that multiply together to give you 18? And then we do the same with 27. So we list 1, 3, 9, and 27. The second step in finding the greatest common factor is to say, what is the greatest or largest number that these two numbers have in common? So the greatest common factor for 18 and 27 is 9. Let's try it again with the numbers 16 and 32. 16 and 32, we've listed out the factors of each of those numbers. And if we look through those numbers and say, what is the largest number that they have in common, then we can circle the number 16 because 32 and 16 are both divisible by 16. And so the greatest common factor for 16 and 32 is 16. Now let's look at a different type of problem. What if we have 16 and 27? Now we've already used both of these numbers. So if we write out the factors of 16 and the factors of 27, what's the largest number they have in common? If you said 1, you're correct. Now, when we're looking for the greatest common factor, 1 is not the answer we want. So if that's the only number that these two numbers have in common, then we call them relatively prime. Now, 16 is not prime because we just listed all of the factors of 16. 27 is not prime because we listed the factors of 27. But when you group these two numbers together and ask for the greatest common factor, then they are relatively prime because the only factor they have in common is the number 1. So numbers are relatively prime if they have 0 factors in common other than 1. They're relatively prime if the only thing they have in common is the number 1. So that's why 16 and 27 are relatively prime. Now, for the next page, you try the numbers 21 and 42. Try the numbers 21 and 42. Pause the video if you want to try it on your own. If you listed out the numbers of your factors for 21 and got 1, 3, 7, and 21, then you listed out your factors of 42 and got 1, 2, 3, 6, 7, 14, 21, and 42. What was the largest thing they had in common? I hope you got 21 because that is the greatest common factor of 21 and 42. Well, there were a lot of terms today, so let's take a minute and review. Factors are all the numbers that divide evenly into a number. A prime number only has 2 factors, 1 and the number. A composite number has more than 2 factors. So a composite number would be like 4 because 1 times 4 is 4 and 2 times 2 is 4. So they have multiple numbers that multiply together to give you the number. What's an example of a prime number? I'm sure that was correct. If you said 3, 5, 7, 11, there's a lot of numbers that are prime. Now, prime factorization is when you list all the prime numbers that multiply together to create a number. Then we talked about the greatest common factor, and that is where we found the greatest or the largest number that two numbers have in common. We list all the factors and find the largest one that they have in common, unless they're relatively prime. Now, what was relatively prime? It meant that the numbers have no factors in common other than 1. I hope this answers your questions on factors. I hope it makes it a little bit easier. There was a lot of information in this video today, but if it was at all helpful, please like and subscribe to Math Mom and check back later so that we can answer all of your math questions.